this whole thing's about 212, okay? 212 is using the Ti84 to graph final velocity versus time to determine acceleration, okay? In the book, they show you a speed in meters per second under a constant acceleration, and you put your time on the bottom axis. And if you look at it, it's the rise over the run. And if the rise is in meters per second and the time below is seconds, you'll get meters per second squared, which is acceleration. And we're going to use this concept and the ticker timer to actually determine the acceleration of the ball falling using the ticker timer. So there's a couple of things we want to look at before we get started with this whole thing. Let's take a look at this first. So we have our timer, right? It looks like this. It's just a strip of paper. Yeah, you've been doing this, okay? And our first set of measurements were pretty easy. All you do is measure the top one and the total amount of dots. This is a little different. If we watch what's going on, 1, 2, 3, 4, 5, you'll get a certain distance based on 5 dots, okay? And you're basically going to just measure from start to here. Then you're going to measure how far it has gone in 10 dots. Of course, it'll be further, right? So if I continue making dots and made 10, come to here, I would get its measurement. Now measuring from start once again, all the way down. How far did it go? In 15 dots, okay? This would be 15. Measure. I'm going all the way from the beginning. And the last one down here would be 20 total dots, okay? What makes this easy is that this is our timing device. So wherever many dots we have, 5 dots, right? If we divide it by 60, that'll give us the amount of time it took to go whatever distance that is. So if I measure this distance, right, whatever the distance is, and if we divide it by the amount of time, we have velocity. But we have average velocity because it's starting from 0, all right? So to get your final velocity, we know that V average is equal to our final velocity plus our original velocity divided by 2. We just simply take the 2, put it up to here. So that's going to be 2 times our average velocity. And if we're starting from 0, we can drop that. So whatever this number is, following our calculation here, V average times 2 would be our final velocity. And then we just plot time, which we get from the dots, time, and we have our final velocity here. We should get a straight line. Of course, it'll be a little sloppy and then weird things going on because it is science and we're actually doing this, right? So let's look at the way this thing's set up on this, okay? It's not hard. You've already learned how to do graphing, all right? But the first column, I just put my dots, 5, 10, 15, and 20. And I'm going to be measuring that on the ticker tape, right? And then the second column, I measure how far did you go in 5 dots. In this case, it was 2.12 centimeters. I got to convert it to meters. This is 8.46 centimeters. I convert it to meters, and so on, 19 and 33. But you have to make sure this is in meters. Always make sure this thing is in meters. I'm going to highlight that, or it's not going to work. So make sure it's all in meters, okay? Then we have L3. To find the amount of time it took, basically you're just taking the list of dots and divide it by 60. That's what this is. And that's where you get L3, right? So that's the amount of time it took. Now look at L4 is just distance divided by time, okay? Remember, this is our distance. This is our time. So this is just distance divided by time. Very easy. And that's going to give us what? Meters per second, or velocity. And we know that we can't use this just yet because it's the average velocity. This is V average. To get final velocity, VF, is going to be equal to 2 times your velocity average. And that's where we get this, L4 times 2. Okay? So it's kind of straightforward at this point. You've been doing graphing here, so it should make sense, right? So the next point is to graph it. So I have to graph my time, and keep in mind L3 is your time. So it says graph the X and the Y. So this is time, right? L5 is average velocity, final velocity, okay? So final velocity, that's going to give us our line. And if you must have, I'm going to write this on here, diagnostic tools must be on. And I show in another video how to do that. But the idea behind it is like you want to make sure you put your diagnostic tools on, okay? If you don't, you're not going to get the R square value. The R square value. This tells us how what? How well the data fits the line. The data fits the line. The closer this is to 1, the better. Okay? This number right here is our slope, right? And actually, this is our acceleration. Now you can see it's 6.10. So we put down 6.10, right? Meters per second squared. And that's when using the ticker timer. And if everything went as planned, and that's the important thing, you should be able to graph this. And when it graphs it, it'll throw a line straight down like you would expect. It should go through all the dots, and if it doesn't, that means something was a little wackadoodle in there, right? So that kind of explains how to do the 212.